All right, consider the following code. Which of the following test values would test all possible output for the algorithm above? Okay, so again with testing, we want to make sure that we test all possible cases. One case would be that y is set to -1. The second case is that y is set to -2. And the third case is that y is -3. The first case would happen if the first condition is true. The second case will happen if the first condition is false and the second condition is true. And the third case will happen if the first condition is false and the second condition is also false, and then automatically the else would run. So the question is, which one of these three test values will make the first condition true, then another test value that will make the first condition false but the second condition true, and then a third value that will make both first and second condition false and automatically run the else. So if we look at our answer choices, all of the answer choices here have 1 in them, right? I'm going to scroll down here just so that I could show all the answer choices. And at the beginning there, we're just declaring X and Y. So we have here on all tests that 1 is going to be used. So let's go ahead and test what does 1, which one of the cases does 1 end up giving us. So I first check if 1 mod 3 equals 0. Well, 1 mod 3 would be 1. When I divide 1 by 3, 3 does not go into 1 any number of times. And when I subtract, I remain with 1. So the remainder is 1 here. So is 1 equal to 0? No. So that means the first condition is false. I go to the else if. Is 1 less than 10? It is. So 1 will end up testing this second case where the first condition is false, but the second condition is true. Now, I can continue with this same strategy of just going ahead and seeing what do the values give me. So what about, let's see what 2 ends up testing. So in the first if, I check 2 mod 3, which again will not be 0. 3 goes into 2 0 times, but this time the remainder is 2. Either way, as long as the remainder is not 0, then that first condition will be false. So 2 equal to 0 would be false. So then we go to the else if. We check is 2 less than 10. That's true. So 2, the value 2, also tests the second case. So based on that, my answer A cannot be the answer, or B or D can be the answer. Because if I have 2 values that are testing the same thing, then I'm going to be missing testing, something here. So moving on, so now we're down to either C or E. So let's see, because we haven't seen what 3 will go ahead and test yet. So let's see what 3 tests. So 3 mod 3. When I divide 3 by 3, 3 goes into 3 one whole time. And when I subtract, my remainder is 0. So actually, 3 mod 3 is, yes, remainder 0. So that's true. So 3 tests this first case. So okay, if 3 tests the first case and 1 tests the second case, then my third number, my third value, has to test the else. Right? So the question is, does 12 test that final else, or does 11? So let's see. What about for 12? So 12 mod 3. Well, if I divide 12 by 3, 3 goes into 12 4 whole times. And so when we subtract, we get 0 as a remainder. So actually 12 will also test that first case. And so again, with C, it will not work out because 1 is testing the second case, but both 3 and 12 are testing the first case. So the third case where y is set to -3 is not tested if I use the 3 test cases that answer choice C has. So just for obviously elimination, my answer is E. However, to fully finish the problem, let's go ahead and plug in 11 and show that it does run that final else. So is 11 mod 3 equal to 0? Well, 3 goes into 11 3 whole times, which is 9. And when we subtract, we get a remainder of 2. So if 2 is the remainder, then is 2 equal to 0? False. So then else, okay, check if 11 is less than 10. False. So then it will run the final else. So the x value of 11 will test this last case. So as you could see with answer choice E, the value of 1 tests the second case, the value of 3 tests the first case, and the value of 11 tests this third case. So E is the only answer option that tests all 3 cases.